Okay, so let's do some other problems together. Hopefully this will help you for the test tomorrow. So I'm looking at this radical, and so I'm thinking I want to complete the square so that I can do trig substitution. So first off, I'm going to pull the things out of the radical and factor the negative out of the first two terms, and then just carry that 5 off to the side. Then I'm going to complete the square. I'm going to go slow. So I'm going to take half of this 2 and square it. So that's add 4. Oh, but I really subtracted a 4. So then I add a 4. So what this turns into is negative x plus 2 quantity squared plus a 9. Now I'm going to put that back into the radical, and I'm going to make sure that I decide to put the negative in the middle. I'm going to do it quick, easy u substitution. So this gives me root 9 minus u squared du. I see it now. I see that I can use u is equal to 3 sine theta. Whoops. And then I'm going to do du is 3 cosine theta d theta. So then putting all that in, I get 9 minus 9 sine squared. And then don't forget to put the du in. That's the most common mistake. Okay, so then I'm going to say, oh, look at that, will you? I'll come back to this. So I get a root 9, which is a 3, and then that 3 gives me a 9. This gives me the square root of 1 minus sine squared. I know that's cosine squared under the square root. So all of that gives me a cosine squared theta total. Well, what am I going to do with that? I'm going to bring it up here. I am going to use the half angle formula. So that's 1 plus cosine of 2 theta d theta. So 9 over 2. Take the antiderivative of 1 in theta land is theta. So 1/2 sine of 2 theta. So then I'm going to take and replace, this is a very important step, because you know I need to go to the triangle next, but I cannot get sine of 2 theta off of the triangle, so you must use this identity. Okay, now let's make the triangle. So where does the triangle come from? This right here. So I get opposite over hypotenuse. This is the other side. Little happy results there, because I know that this is what I saw in the original substitution. So then 9/2, to solve for theta, I'm going to use this and get inverse sine of u over 3. These 2's cancel, and so then I get sine of theta, which is u over 3. Oops, I meant plus, not equal. U over 3, and then times cosine of theta, 9 minus u squared over 3, and then the last step is to put the u's back in, because I want to answer in x's. So my u was equal to x minus 2 over 3, x minus 2 over 3. See if I can squeeze it in here. 9 minus x minus 2 squared over 3. And I will not be taking points off if you forget to put the plus c. Phew, that was a lot. All right, since this one's right here, I'm just going to do this one. Since I see this arc tangent, I know that's something I want to do. I can take the derivative of. So I'm going to do parts. And I'm going to let the dv equal x dx. Remember, u and dv have to take care of everything that's in the integral. So x dx is dv. So v will be x squared over 2. And then here, don't forget to do the chain rule. So du is 1 over 1 plus x squared times 2x dx. Okay, let's put this together. So I have uv minus the integral of v du. Wow, look at that mess. Okay, so let's make sure we clean that up before we try to take the antiderivative of that. So the 2's cancel. I get an x squared times an x, so that's an x cubed. I hardly ever do u substitution, parts, sorry, parts with a fraction, but I can see an easy u substitution will work. So du is 4x cubed. So again, make sure you carry everything along. No little dashy things, right? Not every line. Don't be doing that. So then I get a positive, or this negative carries along 1/4 1 over u du, and then let's see if I can squeeze it in here. X squared over 2 arctan of x squared minus 1/4 ln of u, and I know u is 1 plus x to the 4th plus c.